All right, folks, let's get a show of hands. Who knows what a drone is? Excellent. Keep them up if you've flown a drone.
All right, keep them up if you've flown a drone for science, whatever that means to you. Science, yes. All right, I'm Lindsay Barbieri. I'm a PhD student here at Rubenstein at the Gund, and I use drones in my research. But still, most of the time, people think of drones and they think of military operations or toys. But that's changing.
So my name's Jarlath O'Neil. I'm the director of the Spatial Analysis Lab, which Taylor reminds me is a small d director, and that's where our drone team here at UVM is based out of. Now, these toys, when we couple them with GPS and cool sensors such as cameras or other things, we can do some really, really great stuff. And imaging or capturing the Earth's surface from above is not something that's new. This image that you see here is a Landsat satellite image of Shelburne Bay. The problem sometimes with the existing technologies is they've not taken it the right time, or they don't quite have the amount of detail that we would like to have. So with a drone, we can go out, and this is done at exactly the same scale, we can fly Lake Champlain when the water levels are at flood stage. And we can go in and map with centimeter accuracy where the high water mark is. We can then come back in the fall when the lake's at its lowest and capture this type of change.
Right, and it's not even just from spring to fall. So this here is a picture of a wetland, and this was taken in September. And then because of the ease of flight that we're able to get with these drones, we could come back and image it a month later. So this is October. And you can see that we've had a really rapid change here. And so drones are really useful for capturing that sort of dynamic ecosystem change, such as in vegetation variety, biomass, and water levels. And in addition, with this sort of detailed imagery, we can actually get really good topographic models and do things like simulate where flooding may occur given certain conditions. All of this is really exciting and particularly relevant in the systems that I do research in, which are agricultural systems. So this is a hayfield at Shelburne Farms. So here we're monitoring greenhouse gas emissions. And it's key to note that managed farmland is a significant source of greenhouse gases, and most of the emissions here are actually coming from the spreading of manure. So with drones, we can actually really capture the before and after, for example, which is only a week apart. And this after picture is really important because it gives us a lot of really great context for our greenhouse gas monitoring. We're only monitoring 5 points on the field in terms of the field-based emissions, and this imagery can help us get better estimates of the overall emissions from the field because we can really capture the spatial variability of manure and disturbance on this field. So you can see, for example, that darker streak of manure, we might want to capture that. So these sorts of imagery contexts can really be helpful when we're thinking about where we're missing key or important key measurements and can help us improve our sampling and modeling of emissions at a landscape scale. Furthermore, really quickly, we've been conducting cutting-edge research with Drs. Adair and Galford as well on putting gas sensors on drones and monitoring the atmosphere in flight. So with that, we can get great CO2 emissions from the atmosphere, and we can fly in the morning and then, in the evening on the left, and then in the morning on the right, and you can see there's a big difference in concentrations. So that buildup of CO2 we can actually capture, which really helps us unlock potentially these really critical land atmosphere dynamics. So we're really excited about that.
But we can also use it to help understand the impact of the environment on us as humans. And in Vermont, we're using this technology to help our communities become more resilient in the face of climate change. We set up a long-term monitoring project in the town of Plainfield, which has long felt the financial impacts of these extreme weather events. And with drones, we can not only map the damage, but more importantly, we can fly the stream on a regular basis to understand what's driving these things. We can map the changes in woody debris, look at erosion, and look at changes in the stream channel. And this wasn't some academic project. In collaboration with consulting engineers and regional planners, we helped to come up with a resiliency plan for the town, which recently won a national award for its effort.
So that's great. Drones, we can do a lot of really amazing things with them. If you're interested in any of this, please come talk to us after. We even have one. So thank you.